off the circle has a radius of whatever r is. And in our case, r is 1 on the unit circle, right? And every triangle that we drew in the circle had some x length and some y height, right? Okay? And that's how we made every ordered pair. All the ordered pairs are x comma y. Right? We good so far? Okay. So if you go to page 163, there's two definitions. Sine is y over r, cosine is x over r. If you've ever taken physics before, I'm pretty sure that your physics teacher has told you something like that. But you guys didn't call it r, you called it magnitude. And you did magnitude cosine of your angle to find your x stuff. And you did magnitude sine of theta to do your y stuff, right? Is that a fair statement? Your teacher didn't make this up, watch. What your teacher was telling you was r, magnitude, whatever you want to call it, cosine theta equals x. Which means that if I divide the r over, you're going to get cosine of theta equals x over r. That's where that definition comes from. Same thing with sine. We good so far? And if you flip the page to 164, you'll find tangent's definition, which is y over x. We good so far? Okay, I'm going to go back. You stay right where you were. How many of you have seen this before? Yeah, you do SOHCAHTOA, right? I don't use SOHCAHTOA, but hear me out. This is a triangle from my unit circle. It has an x distance and a y height and a radius of r, right? If I wanted to find sine of some angle theta, sine to you is opposite of our hypotenuse. This is the angle we're talking about, the one we rotated. On that triangle, compared to my angle theta, what's the opposite? Y. And what's the hypotenuse called? Sine is y over r, which you're used to calling like opposite over hypotenuse. And cosine of theta, you're used to saying adjacent over hypotenuse. I'm not going to use the word adjacent and hypotenuse. We're going to use these letters, x, y, and r. What is cosine? X over r. This is the adjacent, and there's the hypotenuse, x over r. Tangent to you has been called opposite over adjacent. What's opposite to my angle? Y. And what's adjacent to my angle? X. So tangent, instead of being opposite over adjacent, is y over x. So it's the same thing you've always learned. We're just calling them different letters now. Okay, so far? Okay, so if you flip for a second to page 169, we're going to do some of those example problems in 1 second. But here's why that's really important. If I want to go find cosine of something, this is why we filled our unit circle out. Let's say I want to find cosine of 45 degrees. What's cosine's definition?
All day.
X over r? Okay, go to 45 degrees. Like, put your finger on the ordered pair at 45 degrees. What's the x part of the ordered pair there? Root 2 over 2. And I'm on the unit circle, so my radius is 1. Root 2 over 2 divided by 1 is just root 2 over 2. So if I ask you what cosine of 45 degrees is, the answer is root 2 over 2. And if I ask you what sine of 240 degrees, no, it's not the same thing. Yeah, let's find something more fun. Sine of, not 240 is okay. If I ask you sine of 240 degrees, sine is what over what? It's y over r. What's y at 240? Negative root 3 over 2, and then the radius is just 1, so this is going to be negative root 3 over 2. And if I wanted to find tangent, let's say I asked you tangent of 300 degrees. What's tangent's definition? Y over x. Go to 300 degrees. What's the ordered pair? What's the y part? Negative root 3 over 2 over what? 1/2. Dividing fractions is easy to flip the second and multiply. Negative root 3 over 2 times 2 over 1. Slashy washy? negative root 3, that's tangent at 300 degrees. That's where everyone found those answers today in class. Oh, I like that.
What?